Hey, what's up? It's Jake from Nimbus DevOps, and we're going to start our developer journey with a little introduction to programming and a little bit of the context with Python. So, I wrote this in VS Code, but I opened it in my browser so I can make it bigger so you can read it. But essentially, this is what we're going to do. So, we'll go over these four things, and this will be the basis of our intro. But before we get into it, we'll get a little bit more into the specifics of Python before we actually install it. And then we'll install it. And then once you set up some kind of interpreter or environment or something like that, then um, and probably go over libraries or whatever and talk about how to run programs and things like that. Uh, we'll get into kind of the actual nuts and bolts of programming. So a little bit of background stuff at first, never hurt anybody, and honestly, this is good to go over before you get into hello world. So what is computer programming? Computer programming is also called coding, right? And you're basically just telling a computer to do something in a language that it understands. So if you ever wondered how this works, so your hardware, let me grab a little Raspberry Pi. So your hardware, right? It has a little board and it has a chip on it, and it understands electricity. That's basically it. It understands the ones and zeros, on and off, right? Electrical on, that's a one. Electrical off, that's a zero. And it's just going off on, off on, almost kind of like Morse code, really, 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 really fast. And the only way that you can communicate with the chip on this board is through binary, right? And above binary, you have a language called assembly, right? And assembly is just a set of instructions and routines that instruct the processor to do things, and that assembly code are routines that the computer understands. And so what we need is something above assembly. So that would be like your low level language, right? Binary, assembly. Once you get up above that, then you're getting to a higher level language. And by higher, it's like if you were stacking these languages on top of this board, you're just getting higher and higher because assembly can communicate with the binary, convert the instructions and routines to binary. Then you get to like C, right? So C as a programming language is something that's a little easier for humans to understand, and it's a little bit more readable. But it's a compiled language, and that C compiler converts all of the code you write in C into assembly instructions, which can then be passed into the chip and ultimately run as binary. So Python is an interpreted language, which means that your computer is interpreting your Python code, converting it into C, and then going down the stack. So in order for the computer to understand Python, Python is actually being interpreted in C, which is compiled into an assembly language or to assembly, which then runs, basically an electrical circuit at the lowest level. So in order for you to be able to code, you have to be able to understand how to speak the computer's language. So we're not actually, Python isn't speaking the computer's language because the computer actually doesn't speak Python, right? It doesn't understand that language, but it is interpreted into something that is compiled into a language that it does understand. So I think that's something that a lot of people don't know. If you're a programmer, you're probably like, well, yeah, duh. So, okay, this isn't for you. All right, not everybody's a genius. So, good job. Make yourself a sandwich. But it is a skill, right? Computer programming is a skill you get better at, and just like you would write, and writing is a skill. We all write, right? So anybody can learn to write, just like anybody can learn to code. But being good at it requires practice and dedication and time invested into becoming better and a drive to want to get better. And so, just like anything else, it's a skill that you can acquire over time, given, a reasonable amount of effort. Um, and I use poetry as an example. Like you can write, but maybe you're not really great at writing poetry. But people who are really good at poetry spend a lot of time taking those writing skills and applying them in the context of poetry. And some people who are really good authors aren't really good at poetry, just like some people who are really good at writing Python aren't very good at writing JavaScript. They're just different languages, different ways of writing um, something that you're telling a computer to do. So computers are actually really stupid, believe it or not. People think computers are going to take over the world. Um, I don't know, maybe that's true, maybe it's not. But my computer by itself is just a sitting hunk of metal and circuits and crystals and a bunch of other things. So by itself, it's not going to do anything. But if you tell it what to do, then all of a sudden it becomes extremely powerful. And it can do very powerful mathematical computations, arithmetic operations, things like that, that can be used to do some really magnificent things like machine learning, AI, running an operating system, a program, things like that. Um, so how do you get good at it? How do you become a poet? Well, good code is fast, right? It's clean and elegant, as in it's like easy to, um, you're not overwriting, right? So if I were to tell you I was going to the store and that's all you wanted to know because that's the only information you needed. If I told you how I was going to, well, I'm going to drive up the hill and then I'm going to go through the roundabout. I'm going to get to the stoplight. And after the light turns green, I'm going to turn right. And then I'm going to merge into the lane and drive down the road. And when I get to the next stoplight, I'm going to turn left and then I'm going to find a parking spot. And then once I find my parking spot, then I'm going to go inside the store. You don't care about that. You just want to know I'm driving to the store. So that would be a more elegant way of describing what I'm trying to actually do, what action I'm going to take. And if it was fast, like it's faster for me to say it that way. It's more elegant and it's easy to understand. So you can code something and write it with 80 lines of code. But if somebody can find a way to write it in 6 lines of code, we would consider that a much more elegant and easy to understand way of coding. The way you save certain things, and we'll get into variables and stuff like that. The way you call things, if you're just calling them A, B, C, D, like an algebra problem, x equals 2, you don't know what x is. X is just something, but whatever it is, it's 2, right? But if I say oranges equals 2, that's easy to understand. You know that I'm representing the number of oranges that a person has with the variable oranges, and that's equal to 2. So if your code is fast, elegant, easy to understand, it's easier to scale, it's easy to refactor, it's easy to test, all these things later on down the road make it much faster. And there's fast things too, like choosing to use one type of approach to solve a problem versus another, where they both do the same thing, and maybe they're both 10 lines, but one of them is executed faster because of the way the language is interpreted and ultimately executed at a lower level programming language like C. And we'll get into all that, but this is just big picture. I'm just giving you a ton of information. I read through the book and it didn't go through a lot of this stuff. I just kind of made an outline for what it did go over, but I felt that some of this stuff required a little bit of explanation just so you have some foundational information on how all this works. So let's talk about the ecosystem. So all of the parts of a computer, your CPU, your memory, your hard drive, your motherboard, everything like those are all just parts in the world, right? And they're all pieces of that inside your computer case is like inside of that little world, right? And you need a way to represent that world. Like what do I tell when I tell the computer I want to talk to the CPU? Like, what do I do? How do I do that? If I want to tell it, hey, go find out how many oranges I have, how do I tell it to do that? And you do that by referring to them as objects, right? So everything in the computer is an object. Your CPU is an object. Your memory is an object. But everything around it too, right? Your monitor is an object. You are an object. Your shoes are an object. The floor is an object. The sky is an object. Everything is an object. So that's just part of the ecosystem that you live in. There's this internal ecosystem inside of what you're building with the computer, but then there's the world around you, and you need to understand that once you start looking at everything as objects, that can do something or that can be defined. I think it's an over explanation of something that's quite simple, and that's that we all look at things as objects. Um, and Python really likes objects, and you'll find out why in later videos. So let's talk about like what kind of features can an object have now that we know what an object is. Well, they can have properties and methods. Those are the two things, the main things they have. And the properties, just like it sounds, are like the characteristics. So let's take you, for example. So you are a person, assuming a human being is watching this, and you may have a property, you may have a gender, you may have a height, you may have a weight, you may have um, an address, a phone number, a social security number, eye color, any number of things. These all describe you as a person. But you also have what are called methods, and those are things you can do. So you can talk, you can jump, you can run, you can sit, you can whatever it is you can do or can't do, whatever your limitations are, and maybe your method is different than other people, right? So if you look at objects, you just need to remember that they have properties, right? Things that describe them, and then you have and then you have methods, sorry, things that object can do. So anytime you're working with objects, you're going to hear us talk about Crud a lot, and Crud is just an acronym and I put it on here: create, read, update, and delete. This is essentially the foundation of every uh, API or application programming interface. So if you're going to interact with an application, even a database is technically an API with an app under it, was connected to storage. All these things are just CRUD operations. So creating something new is a CRUD operation. Reading something, updating something that already exists, deleting something. Those are all CRUD operations. So, and a little bit more detail of those objects. Every object in Python, as soon as it's created, is given a unique identifier, and that identifier never changes. That's its identity. It's also given a type, right? So we call this data types. It could be a number. It could be um, a collection of letters. We call that a string, or well, letters, numbers, characters. It could be, whatever. Your password is a string, right? That's a data type. So an object will have a type, right? It could be true or false, a Boolean type. And we'll get into all that more detail later. But it also has a value, and this value is the only thing that can change. So I described oranges. So oranges are an object. They have an ID that I don't know because it's something that the computer assigns some random bunch of numbers and letters or whatever. But it has a type. It's a string. Oranges is a word. It's a collection of letters, and it's not a number. It's not true, false. It's just oranges, right? So it's a string, and that object has a value. And earlier I said we have two oranges, so oranges would equal 2. So if I just typed, print oranges, it's going to say 2. And so that's how we can use objects. And just like you would do basic algebra, like x is, let's say that x equals 5. Well, x is my variable in algebra, right? So we're going to call that an object. And in programming, we also call those variables. So I have a variable, which is an object. It has a data type of number, right? An integer. And that integer is 5. And it has a value. The number is 5, right? It has an ID that we don't know, and that's fine. Nobody uses that. And then you can start using this to code things. So if you want to add 5 to, you have an Excel sheet that has a billion well, that's too big for Excel, that has 100,000 numbers on it, and you go, I want to know what all these numbers would be if I added 5. You could say, hey, take the number, the first number in your Excel sheet, and add X to it. And it would be like, here are all the numbers if they were 5 greater. And if I said, that's interesting, what are all the numbers going to be if I add 6? And you could make another column and say, hey, I want you to add all these numbers up and go what would these numbers be if they were 6? So I got started in programming with Microsoft Excel, believe it or not. So I'll show you what this looks like. So I'm going to give you a list of numbers, right? So let's define this, and we'll just say list of numbers. Okay, and we're going to go 1, and I'll get really fancy. Whatever this is, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then I go, what happens, question mark, if I add plus 5? Okay, what happens if I add 5? Well, in Excel, you would say equals whatever this cell is right here, A2, plus 5, right? And you've probably done this before. And then you're like, hey, look, it worked. But here's my question. This is where you get to clean code that's reusable and refactorable. What happens if I want to go, hey, I want to ask a different question. What happens if I add 6? Well, now I got to go add 6 and then add 6. Or if you're yelling at me right now, yes, you can just double click. But a better, more functional way to do this that uses an object would say, well, I'm adding 6. What is this? This is like my question, right? So what if I just said, over here, I have a question. And I want to know, add what? And let's just say it's 6, right? And then in here, I could say, hey, it's whatever this is, but instead of plus 6, I'm going to say it's plus whatever this cell is. And I'm going to hit, it's a neat little trick, I'm going to hit F4 so it locks it. So when I drag this down, it's not constantly looking further down as well. And then I can just say, hey, look, it's just taking whatever these numbers are and adding whatever this number is, and that's what it is. So now if I want to know what happens if I add 7? All of my numbers update. What happens if I add 8? All of my numbers update. So in the world of programming, this would be a variable. The variable is my question, and I'll call my question Q for question, right? And Q right now is equal to 8. And this number right here, we'll call this my future value, FV. In fact, I'll say future value, FV. The future value is determined by taking the list of numbers, or we'll call this my original number, ON. We'll just call it O. And my future value is going to be my original number plus my question. So if I were to write this as a math equation, I would say, how do we represent this future value? Well, you'd say the future value is equal to the original number plus Q, right? So this is my algebraic expression. And I've turned all of these numbers into variables, right? So now I could change my original number. I could change whatever, and these are all increasing by 1, obviously, right? So I could just type in some huge number that doesn't start with 0, some huge number, and it would just solve it, right? And that's the power of programming. The power of programming is being able to make shortcuts and make your life easier. That's what we want to do. So many of you have probably used Excel. If you're not a programmer, right? If you are a programmer, you're probably dying inside right now that I even have Excel open. But just stick with me. So if you're used to using Excel and you have a budget or some sort of inventory or a report that you write or whatever, what you want to ask yourself is, how can I turn this report into a dynamic report where every day, right, I just want to know, I'm given a report in my email and I have to copy and paste, all the numbers from yesterday, all the sales goals or the quantities of whatever that we sold or widgets created, whatever thing you did. And I'm gonna copy and paste it from my sheet, right? There's 10 values. So if I go, okay, I've got this number, I've got 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so these are the 10 numbers that I got inputted from yesterday that somebody sent me in an email. I'm just gonna copy and paste that in here, and boom, my report is done, right? Maybe even put a little total at the bottom. No, not a rated text. Hi, how's it going? Bloop. I forgot I'm not doing programming, I'm doing Excel. Equals sum, like that, right? And maybe it's dollars. Black cow. So now what you have is a dynamic report, and you've probably done this Excel a million times, and you're like, wow, I didn't realize it. Yeah, you're kind of just like programming. This is just a way to communicate with Excel, right? So at the high level, when we talked about what is computer programming, we said it's telling a computer to do something a language it understands. Well, right now you're just using Excel as an interface and you're speaking the language that Excel understands in order to do this. So if you don't think you can be a programmer, if you've ever used Excel and you've used a sum function or a function that adds or an average or whatever, multiplies, divides, whatever it is, you are already using the foundations of the programming mindset, right? The abstraction of data through references, you know. And when I say that, what I mean is I'm abstracting this number, but this future value doesn't even have a number. It's just it's a reference to whatever this number plus this number is. Does that make sense? Okay. You're not going to answer me. I'm recording a video. Hi, how's it going? So, anyways, so that's kind of how I would take this this concept that sounds complicated, and just think about it for something you understand. I used Excel for an example, but yeah. So let me know if you have any questions in the comments section, and feel free to ask away. I'll answer all of them, and I'm going to use this Excel concept a lot because I think it's something that people understand. And I'm just going to take like, hey, this thing you do in Excel, let me show you how to do it in Python. And we'll do it in both. And you can kind of go back and forth and be like, oh, I understand what this does now. So yeah, that's it. I'm gonna love doing this because I love coding in Python, and I have not done a YouTube series on Python yet. So I look forward to doing some more, and hopefully this was a little bit more interactive, fun way of learning what is a computer program and what is an object than some of the other stuff that's out there. So so far so good, and I don't have anything to add. The book that I'm reviewing right now, Learn Python Programming third edition. It's an in-depth introduction to the fundamentals of Python, published by Packet. Um, and yeah, off to a good start. I have high hopes for this book, so I guess we'll just wait and see. Bye.